Hello everyone, myself Shalini, working as Assistant Professor in the Department of CSE from Marri Laxman Reddy Institute of Technology and Management. Today I am going to discuss about the topic sets from discrete mathematics. Let us look into this. So set is a well-defined collection of elements, a group of elements. Whenever you want to represent in a form of single entity, then we need the help of sets. So a set can be represented in two ways. One is in the form of individual elements like this, or we can represent in the form of set builder form. So a set can represent any type of well-defined elements. It may be a set of positive integers, or when you want to speak about a set of books or set of pens or whatever it may be. So set is a well-defined collection of elements or objects. So that objects where a set holds internally, they are called elements of the set. So this is how a set can be represented. Every set should be denoted with a name. So in our example, A is the name of the set and the sets are represented in curly braces. So in the example, set A equal to 1, 2, 3, 4, you can directly represent the elements of the set, or even you can denote the property, like which property holds the elements of the set. So here in this example, x such that x is an integer, x is a number where x value is greater than or equal to 1, less than or equal to 4, also represents in the same format like above. So that is how you can represent elements of a set. So here we are having different types of sets. So the first type of set is finite set. So here finite set or infinite set deals with the cardinality of the set, that is number of elements present in the set. So first one is finite set. So if the number of elements in a set are countable or finite, then we call it as a finite set. So this is an example here. We are having totally 3 elements which are countable. So we can call it as finite set. And second one is infinite set. So a set which contains elements that are not countable or that leads to more number of elements leading to infinity. So you can call it as infinite set. So infinity in the sense we don't know where is the ending point or where the elements will stop. So here we are having the elements b equal to 1, 2, 3 and so on, which is nothing but the set of natural numbers. So it keeps on continuing. There is no ending point. Such type of sets are called as infinite sets. And next one is equal sets. So two sets are said to be equal. If they are having same elements in it, then only they are known as equal sets. For example, you are having A equal to 1, 2, 3 and B equal to 1, 2, 3. So exactly the same elements, same number of elements and the same values also, you call it as equal sets. And next one is null set. A set that do not contain any element is known as null set. It is often represented with 5 symbol. You can often represent it with 5 or empty curly braces also says that set is empty, no elements are present in it. And next one is singleton set. So the name itself is telling single. A set which contains only one single element is known as singleton set. Example, here A is a set where it contains only one element, that is 5. And next one is universal set. Universal set doesn't mean that it is having infinite number of elements. What are all the elements we want to consider at that point of time, that is known as universal set. For example, if I want to consider elements 1 to 5 at this point of time, so for this point of time, universal set represents 1, 2, 3, 4, 5. So again, I want to consider U equal to A, B, C, D and so on up till some F. So this is also you can call it as universal set. So universal set doesn't mean that it contains infinite number of elements. Universal set represents what are the total number of elements you want to consider at that point of time. So this universal set is generally represented with capital U. And next one is subset. So a set can be subset, that is part of another set. For example, let us consider there is a set B. This B is a set. So it is containing elements in it and A is part of this B, a sub part of B. So you can call A is a subset of B. That is, if B is having the elements like 1, 2, 3, 4 and 5 and A is having the elements 2 and 4. So we observe here already B is having the elements from 1 to 5 and A is having a part of it, a sub part of it, 2, 4. So you can call it as A is subset of B. So next one is power set. So power set is nothing but a set which is having all the possible combinations of subsets. So a set contains some elements, n number of elements, and if you represent all the possible subset, that is all possible different combinations starting from null set including the same set itself. So in these possible combinations we start with null set, that is empty set, and next we take one element combinations and then two element combinations depending upon the total number of elements in the given set, and finally we include the set itself. The given set itself is known as power set. So here power set is denoted by P of A. So in this example, A is a set which is having two elements A comma B. Then the power set is P of A equal to, so first one will be the null set and second one is one element combinations. One is A, another one is B, and the next one is two element combination A comma B. That's all. So we are including the null set as well as the set itself, the given set itself. So which is called as power set. So this power set contains all possible combinations of subsets starting from null set including the same set itself. So here we can see the total number of elements in the given set are 2 and the number of subsets in this power set is 4. So what do you understand from here? If there are n elements in the given set, then power set can form 2 to the power of n subset possible combinations. So that is, if n is having 3 elements, then power set has 8 elements in the set. So that is about power set. And next one is operations on sets. So what are the possible operations you can perform? So operations represent how you can modify the values in the set. What you can consider is nothing but the operations. So the possible operations are, first one is union. So union of a set is denoted in this form. This represents union here, the symbol of union, and it is performed on two sets A and B. So the meaning of A union B is the elements belong to either A or B or both. That is, whenever you are performing union between two sets, we consider the elements of A or B or both. So even though the elements are repeated or not repeated or only present in A or only present in B, we take the complete set of elements present in A or B or both. In this example, you can see that A is having two elements 1, 2 and B is having two elements 2, 3. Then A union B is elements present in A or B or both. That is, we'll take 1, 2 and in B 2 is there, but 2 is already considered here. So we'll go for the next element 3. So A union B is 1, 2, 3. And next one is intersection of sets. Intersection means the elements present in A and the elements present in B only must be considered. For example, you are having two sets. Intersection is represented with this symbol. And let us consider again A is having the elements 1, 2 and B is having the elements 2, 3. So we take only the common elements present in both A as well as B. Uncommon elements are not considered here. So 1, 2, 2, 3, only 2 has been the common element. So A intersection B equal to 2. Suppose in any case, if you get A intersection B equal to 5 or null set, that means there is no common element at all between the two sets. So this is about union and intersection. Next one is difference of the sets. Difference. How do you find the difference? Suppose set A is having some elements and set B is having another elements. How do you find A minus B? So here that is called the difference of A minus B. So A is having 1, 2, 3 and B is having 2, 3, 4. The meaning of A minus B is consider the elements present in A but not B. So you have to consider the elements present only in A. Those elements must not be present in B. For example, A is having 1, 2, 3. B is having 2, 3, 4 and you are performing A minus B. So you have to consider the elements present only in A, they must not be present in B. Suppose you take 1, 1 is present in A but not B, so we'll take 1. And next go for 2, 2 is present in A as well as B, we don't consider it. And 3 is present in A as well as B, we don't consider it. So what is the answer for A minus B? It is 1. The elements present in A but not B is the meaning of A minus B. Similarly, when you want to perform B minus A, what is the meaning of it? That means the elements present in B but not A. So for the same sets, if you perform B minus A, if you take 2, 2 is present in B as well as A, we don't consider it. 3 is present in B as well as A, we don't consider. 4 is part of B but it is not present in A, so we'll consider it. B minus A equal to 4. So the meaning of A minus B is the elements present in A but not B. B minus A is the elements present in B but not A. And next is complement of the set. So complement is denoted in this way. This is A complement or sometimes denoted as A complement in this way. So this is nothing but the universal set minus A. A complement is denoted by universal set minus A. Universal set is, as we have discussed, the total number of elements we are going to consider at that point of time will become the universal set. So here we are removing the elements present in A and the other elements in U will be considered. That is known as A complement. So similarly, how we have defined A minus B? The elements present in A but not B. B minus A is referred as the elements present in B but not A. Similarly, A complement is referred as U minus A, which means the elements present in universal set but they should not be present in A. See, for example, in this universal set, in our consideration at this point of time, universal set is having 4 elements, that is 1, 2, 3, 4. And A is having 2 elements, 1, 2. So whenever we are finding A complement, which is nothing but U minus A, consider the elements present in U but not A. So here U is having 1 but it is repeated in A also, we don't consider. U is having the next element as 2, it is having in A also, we don't consider. U is having 3 but not A, so consider it. And next element is 4, it is not present in A, so take it. So what is U minus A here? That is A complement is nothing but 3, 4 for the given sets. So this is how we calculate the complement. So complement means universal set minus the given set. So that means we consider the elements present only in the universal set but not the given set. That is the meaning of complement. So they are the main operations that you can perform on any sets, and apart from that you can also perform the symmetric difference between A and B. Suppose if 2 sets are given A and B, you can calculate the symmetric difference between them. So what is the formula to calculate symmetric difference? A delta B. This is A delta B, which can be represented as A minus B union B minus A, which can also be represented as A union B minus A intersection B. This is known as symmetric difference between 2 sets A and B. That is A delta B equal to A minus B union B minus A. And next one is, or you can also represent as A union B minus A intersection B. That is one more operation which you can also perform on the given 2 sets A and B. And next one is Venn diagram. So whenever we want to represent any set or any operation on set diagrammatically, then you can take the help of Venn diagram. Represented, each set can be represented with a circle, and depending on what operation you are performing, you can highlight the area present in the diagram. So here you can see the first operation A union B. So A union B, as we have discussed, the elements present in A or B or both. That means in union, we are going to consider the complete values present in A and B. So here A and B is completely highlighted. And next one is intersection. So as we have discussed, intersection is nothing but the common elements present in A and B only will be considered. So this is only the common part between A and B. This part, other part is not present in common. So only the common part is highlighted here. And next one is difference, that is A minus B. So as we have discussed in the definition here, the meaning of A minus B is elements present in A but not B. The same thing we are representing using a Venn diagram. The elements present in A but not B. We don't consider this common part also because here this common part belongs to B also. So here we have highlighted only the A part. Elements present in A but not B. Don't consider the elements present in common or don't consider the elements present in B also. And similarly the next one, difference B minus A. That is elements present in B but not A. So here also we'll highlight only the B part, eliminating A part or common elements, anything will be eliminated. And next, suppose if you want to represent A delta B, so A delta B can be represented like this. Take two sets A and B, A minus B. So A minus B is this part and B minus A is nothing but this part. So union of these both you can call it as A delta B. And next one is properties of set operations. Whenever you are performing some operations on set, what are the properties that you can implement on them? So the first property is commutative property. That is, whenever you are representing A union B, it is equivalent to B union A also. Similarly, A intersection B equal to B intersection A. And associative property, here A union, whenever you are having three sets A, B, C, the grouping of elements A union B, union C can also be grouped as A union B, union C. Same thing can be applied for intersection also. A intersection B, intersection C can be grouped as A intersection B, intersection C. This is associative property. And the next one is distributive property. That is when both intersection and union are applied here. A intersection B union C is equal to A intersection B union A intersection C. Similarly, A union B intersection C can be implemented as A union B intersection A union C. So whenever the operations are performed, whenever you want to represent any equivalent statement for sets, then you can use these properties and apply. So these are the main properties: commutative, associative and distributive. And coming to the next one, the main laws of set theory. So what are the laws that we can apply? A union B whole complement equal to A complement intersection B complement. So these are also logically equivalent to each other. You can take some values and apply the operations on them and you can find the equivalence between them. Similarly, A intersection B whole complement equal to A complement union B complement. And next one, identity laws, A union null set. So A means, let us take A equal to some elements 1, 2, 3, 4. And the union 5 is nothing but a null set. Whenever you are performing union of both, so union means you have to consider the elements present in A as well as the other set also. So no element is there. So it is nothing but again 1, 2, 3, 4. So we say A union 5 equal to A. Similarly, A intersection universal set. Suppose universal set equal to 1, 2, 3, 4, 5, 6 and intersection A equal to 1, 2, 3 for example. So intersection means we take only common elements. So what are the common elements between universal set and the given set is 1, 2, 3, which is nothing but our original set again. So we can call A intersection universal set equal to A again. So the same thing can be applied for De Morgan laws also. You can take some values, perform A union B whole complement, which will be equivalent to A complement intersection B complement. So these are main laws of set theory. And next is real-time applications. So where do we really apply the concept of set theory is we apply in database queries. So whenever you are performing some search operations, whenever you want to take the combinations while performing search operations, that is some characteristics. For example, a student, you want to search the information of a student like whose percentage is greater than 70. You can have some characteristics in combination like the student belonged to first year or student got more than 70 in first mid and more than 70 in second mid. Only those student details should be retrieved. In that case, you can apply the concept of set theory. And similarly, grouping the elements also. Whenever you want to group the elements of same type, you can consider it as one part of set. And even these Venn diagrams will be helpful for us to represent probability also. So these are the main real-time applications where we use set theory. So these are the references for the content. Thank you.